See, Roger, in Switzerland there's a famous cheese, Emmentaler. It's full of holes.
Okay.
Now, after you ask me all these holes in my brain, I have to ask you a question, because you can explain that much better. Many people, when they come in, and I use both equipments. I use an SpO2 sensor on my finger, and I use the NIRS. They ask me, why do I have to pay $800-900 for something I can buy in your same business for $80?
Okay.
Can you explain in the technological terms that I can bring it over to my clients, that there is actually a fundamental difference between these two, both NIRS sensors?
Sure. Okay, both sensors use the same fundamental physics for their measurement. Both of them sense that hemoglobin changes color depending on whether it's oxygenated or not. The difference between the devices is that the pulse oximeters are designed to measure arterial blood, and they do that by sensing the pulsations in the arteries. So the arteries get bigger and smaller with each heartbeat. And
so that's why you see the pulse rate as well.
That's exactly right. And when they key in on that, then only the arterial blood pulsates. The capillary blood and the venous blood does not pulsate. So by keying in on that, they can measure the arterial saturation. And of course, the arterial saturation is the same through the whole body. So if you measure on the earlobe or the fingertip, no oxygen is consumed in the arteries, or very, very little, in the arteries from the time the blood leaves the lungs until it gets to your extremities. So it's a very systemic measurement, and you get essentially the same reading no matter where you measure.
So that's why I sometimes have problem when people do very high activity to be able to read SpO2, because I may squeeze the arterial a little bit on a high bike handlebar, and then I don't get a proper reading. I need a free flow.
Yep, and they're very motion sensitive, because when your venous blood sloshes around as you move, and then that confounds the measurement. It can't find that little bitty blip in the arteries when your venous blood is sloshing, and so they typically don't work well when you're moving a lot.
So that's where that dream concept comes up. Can I actually get? I don't get a heart rate reading really with that. I only get a pulse reading.
A pulse reading, exactly, exactly. Yep. But now the NIRS, or the Moxy, again, it's using that same physics, but it's making a steady state measurement, which is, it's more complicated, because now a lot of things that don't pulsate, like melanin and water, bilirubin, a lot of those are now in our way. They're optical things that we have to see through. But when we look steady state, we can see what's going on in the capillaries. So the optode design and the algorithm design of the Moxy are designed to go through the skin and fat and measure the oxygen levels in the capillaries and tissue of the muscle. And that's where the oxygen is being consumed. So it's a very localized measurement, because it's the measure of the balance between supply and demand for oxygen in that individual muscle.
So I'm actually sitting there where all happens, where there is the feedback, whether I actually deliver more oxygen than I actually use.
Yep, it's where the action is for the oxygen delivery. So the primary difference is the pulse oximeter measures arterial saturation, the Moxy measures muscle oxygen saturation in the capillaries.
I will be able to explain that now.
All right.
Thank you very much.